Over the next 40 minutes, you will hear from two experts in the field of both CMSs and Amazon Web Services speak about best practices in establishing an AWS environment that can manage enterprise-grade CMS. Before we begin, a few housekeeping items. Regarding the console in front of you, Zoom offers a few controls that you will see either in the top left-hand corner or at the bottom of your screen. Audio settings, chat, Q&A, and raise hand are your controls. Speaking of Q&A, we hope you pose some questions for our panelists to answer at the end of today's webinar. This webinar is recorded and along with a slide deck will be available following the webinar. In a follow-up email to all attendees, you'll be provided a link to both the video recording and the deck. I'd now like to introduce you to today's presenters and panelists. Abhay Kumar is head of project delivery at Priocept. He is responsible for ensuring the effective delivery of all Priocept projects, including Magnolia implementations. Prior to joining Priocept, Abhay worked for Accenture as a web and digital consultant. Joining us from Amazon Web Services is Ruchika Abhi. Ruchika is a solutions architect at AWS. She is also a certified big data solutions architect, focusing on batch, real-time, and predictive analytics. This is Bill Beardsley speaking. I will be moderating today's webinar, and I am General Manager of Magnolia Americas here in Miami, Florida. And on the right-hand side of the screen is Dan Norris-Jones, a technical consultant for Priocept. I'd now like to review today's agenda. Ruchika will kick off webinar discussing business benefits of running your project on AWS. Then Abhay will take it over and cover the second part of the webinar, addressing the technical implementation and management of running Magnolia on AWS. And so with that introduction, I hand over the presentation to Abhay Kumar from Priocept.
Thanks, Bill, and hello, everyone. Just a quick note on Priocept. So we are an AWS consultancy partner and also the leading Magnolia partner in the UK. So we've been around since 2004, helping enterprise clients to deliver business-critical applications, predominantly in the UK, but also with a presence in the US. And our core services are around content management and cloud infrastructure, which is obviously very relevant to today, e-commerce, software delivery, and web operations. So if you need any more information, please look us up or feel free to get in touch, and I'll share my contact details at the end of this presentation. So before we get into the specifics of deploying Magnolia to AWS, I just want to hand over now to Ruchika to give an overview of Amazon's platform.
Thank you, Bill. This is Ruchika Abhi, and I have been working with AWS for over 4 years as a solutions architect, and I have seen a lot of my customers from different verticals deploy Magnolia successfully on our platform. So over the course of next few minutes, I will go over the benefits they realized. Before we do that, a little bit about AWS. So Amazon Web Services is essentially an infrastructure as a service platform, commonly referred to as IaaS platform, that provides a complete set of cloud computing services that enable you to build highly sophisticated, scalable, fault-tolerant, and performant applications and help you exceed business requirements. Also, to highlight why Amazon Cloud is now a new normal. So back in 2013 in a New York summit, Werner Vogels, and he's recognized as one of the fathers of AWS, and he's the CTO and VP of the parent company Amazon. He said that you have to stop wasting time and effort for things that do not matter for your customer. And one of those things is your infrastructure, because it's not a differentiator. At that time, it was a very disruptive comment, and a lot of people couldn't comprehend what he was saying. But over the last 5 years, AWS Cloud has essentially become a new normal. Businesses from different verticals have realized that infrastructure is not a differentiator, and they've embraced our cloud. And what I see on a day-to-day basis is that companies of every size, they are now deploying new applications to the cloud by default, or they're looking to migrate as many of their existing applications as quickly as they can. And essentially for enterprises, the question isn't if anymore, it's really just how fast we can move and what are we going to move first. So let's see why. Sorry about that. So let's see why. AWS can free you up to pursue innovative, high-value business initiatives by eliminating the time you spend on data center maintenance and operations. And this, in turn, can allow you to put more resources on creating, testing, releasing your new products, and innovate faster to drive your customer value and gain new competitive advantage. You would migrate at your own speed, leveraging tools and programs and partnerships like Priocept to help with your cloud journey. And you can do this while simultaneously improving your security posture and compliance efforts. So the first core principle is to focus on reducing the technical debt. And how AWS helps you focus on your core business is first by breaking the cycle of large, risky capital purchases and trades, for greater flexibility via operating expense. It's also referred to as OPEX versus CAPEX. That will eliminate the risk and cost of capacity planning by allowing for you to acquire exactly the capacity you need at any given time, and you would pay for only what you're using. It would also simplify the complex management tasks that are inherent in keeping a data center filled with ever-changing heterogeneous technology and running it smoothly. And lastly, the global operations would be a relatively simple matter of replication. It's important to note, I'm trying to, Abhay, can you move the slide, please? I don't know why my mouse stopped working. Yes, thank you. So it's important to note how AWS provides enterprises build hybrid, flexible architectures. We have built out the broadest and deepest set of hybrid architecture functionality to enable customers to do everything from network security, access control, powering automated workload migrations, and even controlling AWS from on-premises infrastructure management tools if needed. And we'll look into some of those services as we move along, but I want to mention AWS VPC, or Virtual Private Cloud, that helps you provision a logically isolated section of AWS Cloud in which you would launch your resources and then connect it with your on-premises network using IPsec VPN tunnels or our Direct Connect private link to enable that hybrid architecture. One of the main benefits of AWS is that it enables customers to deploy globally in a matter of minutes and not weeks and months, as it would in traditional data centers. Abhay, sorry about that. I don't know what's happening. So AWS has a concept of a region, which is a physical location around the world where we cluster data centers. We call each group of logical data centers an availability zone. I will refer to that as AZ, and so will Abhay going forward. We also have a global network of edge locations, also called POPs or points of presence, not shown in this diagram, but these are the 102 edge locations from where AWS CloudFront, which is the content delivery network, and Route 53 services are offered. For deploying Magnolia on AWS, you would pick a region, which is independent collection of AWS resources in a defined geography. And you would do that based on user proximity, or to meet legal requirements, there could be data sovereignty requirements, and that's what would help you pick a region. Within each region, you have highly redundant clusters of data centers or AZs that are built for fault isolation. They are tens of miles apart. They have separate power on separate floodplains, but they are still connected with low latency, high bandwidth fiber network channels that allow customers to build highly available distributed architectures that also has data redundancy. So currently we have 53 availability zones, 18 regions as you see, and 4 new regions have been announced that will be coming online between now and early 2019. Now, how does AWS help you focus on building? At the core is the heart of our offering. Let's focus at the bottom of this screen in the stack. You will see that core services we offer consist of compute, storage, and database services. We then surround these services and offerings with the range of supporting components like management tools, networking services, and in the middle of this screen, you would see that we have several application augmentation services like that for analytics or enterprise applications, mobile services, IoT, AI, the list just goes on. All this is hosted within our global data center footprint that I just showed you, and that allows you to consume these services without having to build out any facilities or equipments using our redundant global infrastructure. Going forward, I have grayed out the applications that are not relevant to Magnolia on AWS use case, but again, once you are using our platform, you can easily integrate and extend the functionality of your CMS, for example, add AI capabilities, so on and so forth. But today we will focus on the core services. The blue section that you see at the bottom of the screen has compute, which is EC2, Elastic Compute Cloud, networking, that is VPC, Virtual Private Cloud. We have load balancers in the compute category. We also have some other platform services like Beanstalk and ECS for containers, and Abhay will talk about those. I want to emphasize going forward that if you are migrating Magnolia to AWS, if you're running it on-prem already, like with any other migration initiative, every organization will have, their unique set of constraints and opportunities that would guide that journey to cloud. But AWS account team and partners like Precept, we are there to help you every step of the way to go through this iterative migration process. We will help you re-platform your application as needed and go through this closed feedback loop and the phases of your migration. It's very important to note, and actually all my discussions with my customers, this is where I start because security is, essentially ground zero for us as well as for you. It's a moot point exploring new opportunities and initiatives if security and compliance cannot be maintained. And for a long time, most organizations have had to make a choice between moving fast or staying secure. It's a difficult choice, and inevitably always security triumphs all. One of the fundamental benefits of AWS Cloud is that you're able to do both because security of the infrastructure is handled by AWS, and this frees up you to focus on security of your workload and application. So you will be able to move fast and stay secure on our platform. The AWS infrastructure is custom built for cloud, and it has elements designed to intercommunicate well and present the smallest attack surface possible. And in addition to that, we have physical security controls present in our data centers that have been designed to be the most stringent in the world. This pursuit has led to AWS being trusted by governments, military organizations, financial institutions, including global banks, healthcare institutions, and other highly sensitive organizations. And one of the reasons is that our security team is monitoring the infrastructure all day, every day, and is well connected with all major security watchdog groups and vendors to ensure that potential threats are identified and remediated immediately. And we are able to do this because we operate at a massive scale. And by looking across more than 1 million active accounts each month, running virtually every conceivable type of workload, we can see the issues that may occur, once in a billion operations multiple times a day. And that kind of visibility and response isn't achievable with majority of organizations if they're running their, workloads and managing themselves in a data center. The set of security tools that we offer going forward is incredibly powerful. So you would see it divided by different categories. So these tools will help iterate you over different processes of control, prevention side of things, monitoring for governance purposes, and also remediating and fixing the problems. So just protecting is not enough. You have to continuously monitor and fix any issues, and that's where the DevSecOps, mindset kicks in. So it's fully integrated, as you start using our tool set. We have achieved a number of internationally recognized certifications and accreditations that demonstrate compliance with third-party assurance frameworks. So this list is essentially growing. It's not an exhaustive list. There might be more updates on our websites, but you can see that we do cover all of the major compliance accreditations, and you can have workloads that are PCI, HIPAA compliant, FedRAMP compliant workloads, and other internationally recognized compliance and regulations are listed here as well. One of the great things I want to mention is that AWS customers would inherit all the best practices of AWS policies, architecture, and operational processes that would help you satisfy your, security requirements. The most important thing is the shared responsibility model for security that we have. It's essentially a collaborative approach between us, AWS, and you as a customer. So we will help you achieve security in the cloud with the extensive set of tools that I spoke about. But then AWS will manage the security of the cloud, which is essentially everything below the hypervisor layer, and everything above the operating system or hypervisor layer is where you would have to focus your attention on. So for running Magnolia on AWS, we would partner closely with you for your security objectives initiatives. And talking about what AWS will manage for you, that will be multiple layers of physical and network infrastructure security, operational security, data centers that are nondescript facilities, role-based access. We do the audits. We have MFA access, systemic change management, safe storage, decommissioning, network protection. You don't have to worry about any of that. But going up in the stack, you as a customer would be managing your operating system, network and firewall configuration, classifying your data, identifying the sensitive data and encrypting it using the tools we provide. And again, monitoring your traffic. So I would pass on to Abhay now to talk about technical aspects of Magnolia on AWS, and in the end, I'll be happy to address any AWS specific questions.
Thanks, Ruchika. So I'll now give an overview of the specific considerations for running Magnolia on AWS. But it's worth noting that the concepts covered here could equally apply to any other cloud platform. So I'm starting here with a fairly complicated diagram, so don't worry too much about detail, unless of course you're an AWS expert, in which case feel free to ask questions at the end. But what it's describing is a typical Magnolia implementation within AWS. So you can see we're using AWS features such as auto-scaling groups for public or delivery web servers, which I'll talk about in a bit more detail in the next few slides. And you can also see use of AWS security features such as the virtual private cloud, VPC, which is logically isolated network within the AWS cloud, which Ruchika mentioned earlier. And you can also see different subnets within the VPC used for public servers, content authoring servers, and the database layer at the bottom there. And each of those has different security configurations applied based on their concerns. So it's a very scalable and secure Magnolia implementation, and it's made possible by use of AWS features, out of the box. So I mentioned auto-scaling groups in the previous slide. As a quick overview for those of you not familiar, an EC2 auto-scaling group in AWS is a specification for a set of servers. They have three main functions: auto-scaling, which means that AWS will automatically handle the creation and destruction of instances based on load, which I'll explain a bit more on the next slide. And they also provide auto-healing capabilities, which means terminated or failed instances will automatically be replaced. So they are in essence self-healing. So for that reason, it's best to always use auto-scaling groups, even for a fixed number of servers, such as for the Magnolia Author server, even though you don't need that to auto-scaled. You still do want it to self-heal. The other benefit of auto-scaling groups is that you can use the auto-healing nature of instances to configure zero downtime rolling updates. So you can kill an instance and have it rebuild itself with the latest code. And you can do that sequentially across your public instances and ensure zero downtime for your web application. So use of auto-scaling groups for the Magnolia public and for the Author web servers is recommended. So to quickly summarize the benefits of auto-scaling, this diagram shows the old-fashioned way of doing things, which is still present in my experience in many organizations. The diagram here is showing a set of Magnolia public web servers serving a hypothetical website. So you can see here there are 8 physical servers in a data center which have been commissioned to be able to cope with the expected maximum peak capacity for this site. And so it's assumed that the maximum load on the site can be handled by these 8 web servers. So on Monday, you can see a capacity of just over 3 servers, and Tuesday, just over 2. And then on Wednesday, you can see just over 4 servers and so on. But on every day, there is always a fixed capacity of 8 servers available. So on each day, there are always a number of servers idling, everything above the line, basically. So everything above the line here is unused or wasted capacity. Even when the servers aren't in use, you're still paying for this capacity in terms of power consumption and maintenance costs. With cloud platforms, you can solve that problem by having the infrastructure automatically scale up and down to meet demand. You only pay for the time servers are running. AWS charge for the first hour, and then for every minute that infrastructure is running thereafter. There is still some slight overcapacity, as you can see on each day, but the amount spare is considerably smaller than on a fixed set of servers. So this is a much more cost-effective approach to running your cloud infrastructure. With this in mind, there is a particular challenge when deploying an enterprise CMS, such as Magnolia, to an auto-scaling platform such as AWS, which I'll explain over the next few slides. So let's start by looking at a standard CMS architecture and comparing how that differs to Magnolia, which is built with scalability and high availability as core considerations. So in the model described in this illustration, you can see a CMS server, which is where you do your content editing, so it's the author server in the Magnolia world, and delivery servers that are publicly accessible and serve published content for a website or a group of websites. So again, they're the public servers in the Magnolia world. So this is a model that we're familiar with, and it works nicely for small to mid-sized deployments. But as you can see, there is contention for database operations. The delivery servers are making read requests to the database at the same time as the content editors are making read-write requests. So a high content editing workload can slow down the website's performance. And conversely, high website traffic can slow down the content editing experience. And there is also a single point of failure in the database, which you can see in the middle. So really this is a bad application architecture and not one that I certainly recommend or Preset recommends, but it does lend itself nicely to auto-scaling, because you can spin up a new public web server and it will start serving out the latest content because it's connected to that central database. So architecturally, this solution is bad for a number of reasons, but it does make auto-scaling pretty easy. So how does Magnolia differ? Magnolia differs in that there is a physical separation between authoring and public environments. So content is physically pushed from authoring to public servers, which is actually an import-export process with content transferred across HTTP. So this approach solves all the contentions issues that we saw on the previous slide, as Magnolia has separate databases for each environment, which you can see on the public web servers there. So there's one for the authoring server and one for each of the public web servers. So for an application architecture perspective, this is a much cleaner approach. But this does pose a problem when deploying to auto-scaling cloud infrastructure. So here's the problem as it relates to auto-scaling Magnolia instances. In this example, there was a sudden rush of demand, again, for this hypothetical website. So an advert aired, for example, or the site got rate shopped, or a social media promotion went live, and any of these things caused a sudden spike in traffic. So this caused public web server 3 to be created, which you can see here in grey at the bottom. And the problem is that public web server 3 doesn't have the latest content on it. In fact, it doesn't have any content yet. So bringing this server into the load now would be, a bad idea. You'd be serving out a blank site to 1/3 of visitors to your platform. So the problem is simple, and there is a solution, but it isn't completely straightforward, as it requires orchestrating events between Magnolia and AWS. So here are some of the core services required to set up auto-scaling for a Magnolia implementation. As mentioned, we use EC2 compute instances for running Magnolia public and author servers, and these are configured in auto-scaling groups. And we use RDS for data persistence for the author Magnolia instance, which we showed earlier was configured for multi-AZ, as in multi-availability zone redundancy, which Ruchika spoke about. And we use Lambda to make REST API calls into Magnolia to notify the addition or removal of Magnolia infrastructure. And we use S3 for storage of Magnolia publication keys, or the Magnolia publication key that is required to authorize activation between the author and public servers. And we actually also use it for the WAR file, the web application archive file that we use to build EC2 instances, which I'll talk about a bit in a minute. So here's how we orchestrate events between Magnolia and AWS. The objective is to bring public servers into the load only when they have the latest content on them. And to do that, we basically set up various AWS services to call into Magnolia REST endpoints. So at the top here, you can see we have a lifecycle hook configured on EC2 on the EC2 autoscale group. That triggers events when Magnolia EC2 instances are created or terminated by calling Lambda, the Lambda function, and it does that via SNS, which is the simple notification service, another service within AWS. And then the Lambda function then calls into Magnolia to notify that a new instance has been added or removed. So if it was added, then we use the Magnolia synchronization module to push the latest content to the newly added public instance. So on the left of the diagram here, you can see that there is an autoscaling group health check configuration, which is used to check the status of the public server, and that's just a standard health check configuration within the autoscaling group. And it calls a custom Magnolia health check API, which will return a 200 status, i.e. healthy, if the server is running and has the latest content, and then the new server can be brought into the load. So there are quite a few steps there, but we at Precept have deployed this process in a robust manner for a few clients now, so we know it works well. Clearly, auto-scaling doesn't happen instantly with this approach, depending on your content, but it can take roughly around 10 to 15 minutes for the process to complete. So you need to make sure you configure your auto-scaling thresholds accordingly. For example, you might want to scale up at 70% capacity, for example, rather than waiting longer than that. So a note on EC2 instances. These are generated from an Amazon Machine Image, or AMI, which is an Amazon virtual machine. At Precept, we use something called Ansible to handle the configuration of software on servers, Ansible being an infrastructure as code solution. And the way we use Ansible is we set up the Ansible scripts to fetch the Magnolia application, which is packaged as a WAR file from an S3 bucket. And then we use the autoscaling group rolling updates to sequentially update each EC2 instance. So that ensures zero downtime, which is a point I discussed earlier. The final consideration for deploying Magnolia to AWS is the public key exchange process. So you need a public key to authorize publication from an author to a public instance. So what we've set up is that on initial startup of the author instance, a new public key is generated, and we then store that in an S3 bucket. And then the newly created public instances will then retrieve that key from the S3 bucket when they're created, and then they'll pull those locally and store them. So that's the core concepts covered. There are a few other things worth mentioning. Firstly, containerization. So Magnolia, like any other application really, can run inside a container using engines such as Docker. Docker is useful if you need to run hundreds of instances on shared infrastructure, and also if your solution follows a microservices architecture where there are lots of small service layers and many API endpoints running on different nodes. If that does describe your solution, then you can use the Amazon Elastic Container Service, or ECS, which is a container orchestration service that supports Docker containers if you do need to go down that route. And at Precept, we have deployed Magnolia in Docker containers to AWS. So if you need any advice on this, then please feel free to get in touch. So a note on Beanstalk. So Elastic Beanstalk automates infrastructure creation. It's useful for smaller Magnolia implementations or for demonstration purposes, but we don't recommend it for large-scale Magnolia deployments. That said, Magnolia can work on Beanstalk as it can be single file deployed, and you can configure a single RDS instance for all the public servers that you need. But the orchestration needed to autoscale new Magnolia public instances requires a bit of work in terms of creating custom autoscaling lifecycle hooks. So Beanstalk only really makes sense if you're not doing autoscaling for Magnolia applications, which kind of defeats the purpose of using Beanstalk. Finally, I wanted to mention that for enterprise clients, Magnolia provides a set of additional modules that can help with some of the challenges that we've described. So if you want any more information on these, you can speak to your Magnolia partner manager, or feel free to get in touch with Precepts, and we're certainly using some of these things on our projects. So to summarize, Magnolia is an inherently cloud-friendly platform that is architected to work well on any cloud platform, including Amazon Web Services. It requires some special configurations, as described, to achieve a fully elastic solution, but the benefits of this are a robust and highly scalable Magnolia implementation. If you want any more information on any of the topics covered in this presentation, then please feel free to get in touch. Thanks for listening today. We will now answer any or at least some of your questions that you might have.
Good. Thank you, Dan. And Ruchika, I think this next question is for you. What are the cost differences of running Magnolia on-premise versus in AWS?
Sure. So that would depend on the size of the workload and the size of the content database. We have a team that would help compare the cost of total cost of ownership of having Magnolia on-prem and also on our platform. But as Dan said earlier, there are a variety of instance types to choose from, with a different mix of resources, for example, compute, memory, networking, and depending on which type and which size you pick, the cost will vary. The overall rule of thumb is that it would be cheaper to run Magnolia on AWS because it's scalable infrastructure, and you'll be able to scale out, say, your authors and web servers based on the load, or just do scheduled auto scaling. For example, if you have a system that runs that is extensively used during the daytime or during the weekdays, but not so much during the nighttime, then you would scale it down using a scheduled cron function or something like that. So there are ways to cost optimize your Magnolia deployment on AWS, and that's how you would go about cost savings exercise after you have deployed. And I know it doesn't answer the question, but we'll have to take it offline to understand the size implications and then get into the costing exercise.
Fair enough.
Mm-hmm.
Thank you, Ruchika. Okay, another question. How are the keys secured in the S3 bucket?
So that's really just a function of the S3 security configuration. And also the EC2 instances have something called an instance profile, which is the security credentials under which the EC2 instance is running. So the best approach there is to set the S3 buckets up so that they can only be accessed by a certain instance profile, and then run the EC2 instances in that profile. And then the EC2 instances are the only piece of infrastructure that can read those keys.
Great. Thank you, Dan. Okay, that's it for the Q&A. And this concludes the session of our first webinar series, first in a series of webinars brought to you by Precept and Magnolia. Thank you very much for attending. Appreciate your time. And as I mentioned early on, there will be a follow-up email with a link to the video as well as the opportunity to download the deck. Thank you very much, and enjoy the rest of your morning, afternoon, or evening as it may be. Bye-bye.